1996, Michael Behe published a book titled Darwin's Black Box. In it, he argued that natural selection, Darwin's designer substitute, could not explain the origin of the bacterial flagellum or any other irreducibly complex biological system. Instead, Behe concluded that the integrated complexity of these systems pointed to intelligent design. Darwin's black box created immediate controversy. Over 75 publications, including some of the world's leading newspapers and scientific journals, reviewed the book. Some scientists praised Behe's work, while others dismissed it as unscientific and religiously motivated. Behe's critics also insisted that he had underestimated the power of natural selection. They argued that the flagellar motor could have been constructed from parts used to build simpler molecular machines, like this needle-nose cellular pump. If the components of the pump already existed, they could have been preserved by natural selection even before the bacterial motor arose. This theory is called co-option.
It's essentially saying that evolution or natural selection at some point was able to borrow components of one molecular machine and build a new machine with some of these components.
Scott Minnick has studied the flagellar motor for nearly 20 years. His research has led him to challenge the co-option argument.
With a bacterial flagellum, you're talking about a machine that's got 40 structural parts. Yes, we find 10 of them are involved in another molecular machine, but the other 30 are unique. So where are you going to borrow them from? Eventually, you're going to have to account for the function of every single part as originally having some other purpose. So you can only follow that argument so far until you run into the problem of you're borrowing parts from nothing. But even if you concede that you have all the parts necessary to build one of these machines, that's only part of the problem. Maybe even more complex, I think more complex, is the assembly instructions. That is never addressed by opponents of the irreducible complexity argument.
Studies of the bacterial motor have indeed revealed an even deeper level of complexity. For its construction not only requires specific parts, but also a precise sequence of assembly.
You've got to make things at the right time. You've got to make the right number of components. You've got to assemble them in a sequential manner. You've got to be able to tell if you've assembled it properly so that you don't waste energy building a structure that's not going to be functional.
Building a molecular machine has been compared to the construction of a house, where workers follow a detailed blueprint and plan for assembly. The foundation of a house is poured before the walls are erected. Plumbing and electrical fixtures are installed prior to enclosing the walls of the structure. Windows must be hung before siding is applied, and shingles are attached only after plywood sheets are nailed to the rafters. So it is with the construction of a flagellar motor.
You build this structure from the inside out. You are counting the number of components in a ring structure or the stator, and once that's assembled, there's feedback that says, okay, no more of that component now. A rod is added, a ring is added, another rod is added, a U-joint's added. Once the U-joint's at a certain size and a certain degree of bend, about a quarter turn, that's shut off, and then you start adding components for the propeller. These are all made in a precise sequence, just like you would build a building.
To build a motor correctly requires a complex system of machines that coordinate the timing of the assembly instructions. But how could natural selection construct such a system?
The co-option argument doesn't explain this. You see, in order to construct that flagellar mechanism, or tens of thousands of other such mechanisms in the cell, you require other machines to regulate the assembly of these structures. And those machines themselves require machines for their assembly.
If even one of these pieces is missing or put in the wrong place, your motor isn't going to work. So this apparatus to assemble the flagellar motor is itself irreducibly complex. In fact, what we have here is irreducible complexity all the way down.
We know a lot about the bacterial flagellum. We still have a lot to learn, but we know a lot about it. And there's no explanation for how this complex molecular machine was ever produced by a Darwinian mechanism.
150 years ago, scientists did not know about irreducibly complex molecular machines. Yet Charles Darwin anticipated the difficulty that systems such as these could pose to his theory.
If it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down.